Welcome to the course Java SE17 Fundamentals. In this module, we'll see what's involved in creating our first Java application. As we go through this module, we're going to start building up the fundamental skills that we need to work effectively as Java application developers. So the first thing we're going to do is create and run an application as a developer does that. We're going to use a tool called IntelliJ IDEA. Now once we do that, we want to see what it's like for an end user to run our application. So we'll see how we can run the application directly from the command line without having to have an entire development environment. From there, we're going to look at the basic statement syntax of Java. So we'll see how statements are structured within the Java programming language. After that, we're going to look at comments. Comments allow us to incorporate text into our application that's not processed by the compiler. And there are two fundamental types of comments: line comments and block comments. Then we're going to finish up with a look at packages. Now, packages are a really important concept, but there's a few fundamental things we need to understand about packages in order to get us started. And that's what we're going to focus on in this module. This course was created using the displayed versions of each of these tools. So it was created with this version of Java and this version of IntelliJ IDEA. The information in this course is applicable to the following version of each of these tools. It's applicable to these versions of Java and these versions of IntelliJ IDEA. So now to kick off the course, the first thing we'll do is build a really simple Java application. And the reason we do that is that I've found whenever I'm working with a new language or a new environment, it's really helpful to build a simple application and run it just so I can see how everything works. Now the tool we'll be using throughout this course is something called IntelliJ IDEA, or more commonly known as simply IntelliJ. And it's one of the most popular environments for creating Java applications. So now to create our application, we'll need to create a new IntelliJ project. So we have this option here, Create New Project. I'll go ahead and choose that. Now when I create a new project, I have to tell IntelliJ what kind of project I want it to be, because IntelliJ supports a number of different languages and a number of different target environments. So over here on the left, we want to make sure that we have Java selected. Then I can head down here where it says Next, and I'll click on that. Now the next thing I have to specify is whether I want to use a template to create the project. And a template simply gives you some initial starting code to get you off and running and building your application. So I do want to go ahead and use a template. So up here where it says Create Project from Template, I'll go ahead and click that box. Now by default there's only one template, which is a command line app. And that's basically the simplest type of Java application you can create. So I'll go ahead and keep command line app there. Go down here where it says Next, I'll go ahead and click on that. So now the next thing I need to do is name the application, and I'll name it First App. Then once we name the project, we need to specify its location. You can see there that IntelliJ is specifying a location to place my project. I like that location, so I'll just go ahead and stay with that. Then the last thing we have here is something called Base Package. Now we'll talk more about packages later in this module. For now, I'm just going to go ahead and set that field to be a blank. So now with that, we're all set to create our project. So we'll head down here to the Finish button. I'll go ahead and click that. Now once our project is created, we can see we have source code here on the right side of the screen. On the left side here, we have what's called the project view or the project window. That simply shows me the contents inside the project. Now the first node here is First App, the name of our project. Let me go and expand that. And there's a few folders under there, but the one we're interested in is this guy SRC, our source folder. I'll expand that. You'll notice that under there, we have a file called main. And this main file is the source code file that we're currently looking at. If we look at that file, you see that it contains a class named main. For now, you can just think of a class as something that can contain sections of code. Now when we create an application, the name of the class doesn't matter. But what does matter is the name of the method within the class. Notice we have a method here named main. And the entry point for an application always has to be a method named main, and it has to have the same modifiers and the same look that this method does. So it has to be public static void. As we go along, we'll talk about all those things mean. Within the parentheses, we have to have the same content we have here with main. So that's a specific style of entry point that the Java environment is going to look for when our applications run. We'll talk much more about all these things as we go along. So let's go ahead and add a little bit of code to our application. So we have this line here where it says write your code here. Let me start out by removing that. So now with that gone, let's add some of our own code. So I'm going to start out by saying system.out.println. And that system.out.println is simply a mechanism that lets me display information to the screen. The information I want to print out will be a quoted string. We'll say first line from app. Then after that, I'll add a semicolon. So what that'll do now is print out the text first line from app when I run the application. So let's go ahead and add two more lines here. One that says second line from app and one that says third line from app. So now with that, we're ready to build and run our application. Now fortunately, IntelliJ manages that process for us. We can simply tell it that we want the application to run. It will take care of the details of building it first. Now there's a couple different ways we can run it. One way, set up to our menus up here where it says run. I'll go ahead and expand that. Then down under run, you see there's an option that says run main that has a green arrow next to it. So if I selected that, it would build my application and go ahead and run it. But you'll notice if I go ahead and collapse this menu, on the toolbar off to the right here, we have that same green arrow. Well, if I click on that green arrow, it will do the same thing. Build and run the application. So let me go ahead and select that. And then once I do that, IntelliJ took care of building the application for me, launched it, and it shows me the output in this window down here at the bottom. So we can see the output from our application, first line from app, second line from app, third line from app. So that shows us that we've successfully created, built, and run our first Java application. So in our next clip, let's take a closer look at the parts of our Java environment. When you first start working with Java, you'll find you run into a lot of acronyms, and all these acronyms can sometimes be confusing. So let's take a look at some of the key acronyms involved in developing Java applications. Now one of those acronyms is the JRE. The JRE simply stands for the Java Runtime Environment. The Java Runtime Environment is what enables our Java code to execute. The issue with Java is that because Java is a cross-platform environment, when you build your Java application, it doesn't contain the native code that can run in a host environment. It contains what are called bytecodes. And those bytecodes have to be able to be translated somehow and able to execute within a particular host environment. It's the JRE that makes that execution possible. Then we have the JDK. The JDK is the Java Development Kit. It's the Java Development Kit that provides the tools that are required to create our Java applications. Now, strictly speaking, the JDK is something that's provided by Oracle Corporation. But there's also an open source version known as the OpenJDK. Fundamentally, they behave very similarly. The key difference is the licensing. The JDK provided by Oracle is licensed under Oracle, where the OpenJDK is an open source license. Now, as developers, one of the most important acronyms to us is the IDE. Right? The IDE is our integrated development environment. And throughout this course series, the IDE we're using is IntelliJ. And it's the IDE that we interact with to edit, build, run, and debug our applications. But the IDE does not stand alone. It has to cooperate with the JDK and the JRE. So let's see what our setup looks like for us as developers. So we're going to start out again with our IDE, and that's where we edit our application code as well as initiate the builds and the runs. But the IDE is not doing all that work on its own. When a build has to be done, the IDE cooperates with the JDK. So we're in our IDE and we launch our build, it's actually passing that work off to the JDK. And it's the JDK that actually produces our Java application. Now when we produce that Java application, we want to run it in some host environment. And again, that might be our Windows operating system, our Linux operating system, Mac operating system, or some other host environment. And that Java application can't run directly in that host environment because it's platform agnostic, right? It contains these things called bytecodes. So it's the JRE that allows the application to run. So although our developer experience may appear to be happening entirely within the IDE, it's cooperating with the JDK to do the builds and the JRE to execute our application code. Now you may be thinking, well, that's a pretty complex setup environment. What about users who want to run my applications? Well, for the user, the setup is much, much simpler. Now, of course, a user is going to start out with some host environment. Again, it might be Windows, Mac, Linux, or something else. Well, in the user's host environment, all we need to do is have the JRE installed. Once that JRE is installed on the host environment, Java applications become just another application to the user. The user can simply install that application, and as far as they're concerned, they run it just like any other application. So now in our next clip, let's see what it's like to run the application we just created as a user might run it. Earlier in this module, when we ran our application, we ran it from directly inside of IntelliJ. In other words, we ran it from directly inside of our IDE. Well, end users won't have access to the IDE. So the question is, how does an end user run our application? Well, the first thing they'll need is a copy of the application itself. And that's this file here, main.class. Remember that when we created our application, it contained a class file named main. Well, when we built this application, the compiler created this file, main.class. So main.class is the compiled version of our class main. Now to find that file, you'll first look in your project folder. Then when we did the build, IntelliJ created some additional folders. Created an out folder, then a production folder, and then another folder named after the project. Now since our application is a command line application, we'll need to run it from the command line. Now a shortcut that we can use to launch a command line that's already in this folder is head up here to this box at the top. I'll go ahead and click on that. I'll type CMD. I'll hit enter. So now I have a command prompt that's already located at the correct folder. To confirm that it's correct folder, let's do a directory listing. So I'll type dir. I'll hit enter. And when I do that, you can see our main.class file. Now since the main.class file is a program, it might seem like we could simply type the program name and then run it that way. But notice when we do that, we get a message that says that main is not a recognized command. And the thing we have to remember is that Java applications are not native applications. They have to be run from within a Java environment. So to create that Java environment, we'll need to use the Java command. So the Java command will launch an application into that Java environment. So we'll specify our class name. Now something that's very important to remember, class file names are case sensitive. So now that we have our Java command followed by our class file name, I'll go ahead and hit enter. And now you can see that our application ran. So that shows us that what the end user needs in order to run our application is two things. A copy of the application, which is the class file, but they'll also need this Java command. All right, in our next clip, let's take a look at how Java statements are structured. As we build our applications in Java, we're going to do that using a series of statements. Now there are a number of different types of statements in Java, and we'll look at the various types of statements as we go throughout this course and throughout this course series, but fundamentally, programs are made up of statements. So in our earlier application, when we wrote content out, we did that using a statement. Now there are a few things to understand about how statements are structured. First of all, statements always end with a semicolon. Java is a language where the new line character in general doesn't really have any special meaning. The way we indicate that a statement is ending is by using that semicolon. Now statements can contain 0 or more white spaces. White spaces simply serve as visual separators. So in the statement we have here, we have a single space after the opening parenthesis and a single space before the closing parenthesis. And white spaces aren't limited to the space character. White spaces include the space character, the tab character, and the new line character. In other words, the enter key is just a white space. So this nature of white space gives us a lot of flexibility in how we structure our statements. So we can write a statement like this, where we have a few single spaces in it. We can write the same statement with no spaces, or the same statement with a mixture of spaces throughout it. Or we could even write it like this, where there's a mixture of spaces and new lines mixed throughout it. No matter how you format the statement with white space, there's no change in the statement's behavior. It's the statement content that controls the behavior. White spaces have no effect. All right, so now in our next clip, let's take a look at comments. Java allows us to place comments within our source code. And a comment is simply a string of text that's ignored by the compiler. And there's a few common reasons we use comments. One is to simply place human readable notes within our source code. It just allows us to annotate within the source code the work that we're trying to do. could be useful to me as the person creating the code, so when I come back later I can remember what I was doing. It could be really useful to someone who has to maintain the code. Now also, we sometimes use comments to hide source code without deleting it. Maybe we have one or more statements that we don't want to have run right now, but we don't want to delete them. Well, in that case, we can use a comment to prevent the compiler from processing that statement. Java supports 3 general types of comments. One is what we call the line comment, and that's indicated by the // characters. And a line comment tells the compiler to ignore the text until it reaches the end of the current line. Now this is a case where the new line character actually matters. The compiler will ignore everything after the // until it reaches a new line character. Now another type of comment is what we call the block comment. A block comment begins with a /* and continues until the */ is reached. And all text within that block is ignored. And this allows us to have comments that start and end within a particular line or even span multiple lines. And there's another type of comment known as a JavaDoc comment. And a JavaDoc comment begins with /** and ends when it reaches the //. Now from the compiler standpoint, a JavaDoc comment is treated just like a block comment. So all the text between the opening and closing characters are ignored by the compiler. But the key thing is that JavaDoc comments can be used to generate documentation. Now the details of JavaDoc are outside the scope of this course, but fundamentally what it does is provide a syntax that allows us to write documentation for our code directly in the source code. Okay, so now in our next clip, let's see how we can use line comments and block comments within our application code. Here we are back in IntelliJ, and what we want to do now is see how adding comments affects our application code. So let's start out by looking at line comments. So we have this line here where we write out our first line of output. Let's add a line comment to the end of that line. So remember that we indicated our line comment by using //. And as a line comment, that // indicates that everything should be ignored until we reach the end of the current line. In other words, until we reach the new line character. And you can see there that the text "this is a line comment" appears in a different color than the rest of our source code, indicating that it's a comment. But remember that as a comment, it doesn't affect our application behavior. So if I go up here and I run my application, you can see the output of the application is exactly as it was before I added the comment. Because again, the comment is ignored by the compiler. But now because the comment is ignored by the compiler, we can actually use comments to comment out existing code. So we have this line here where we write out second line from app. If I don't want that code to run, I can simply put the // at the beginning of that line. And you notice that once I do that, that entire line appears in the same color as the other line comment I had. Because as far as the compiler is concerned, that's no longer an executable line of code. It's just a comment. So if I run the program again, and notice that our output only says first line from app and third line from app, because the line that said second line from app no longer runs. Now of course we can use line comments on a line by themselves. So up here, let's go ahead and add a standalone line comment. And again, as a comment, it has no impact on the execution of our application. It simply gives us the opportunity to include some additional text within our application. All right, so now let's take a look at block comments. So let's go up here and we'll start a block comment by saying /*. So we have that /* to indicate the start of a block comment. Now one thing to keep in mind, when we say /* or /*, we're talking about the exact same characters. They're just two different ways of saying the same syntax. It's the syntax we use to start a block comment. Now once we have the block comment started, of course we want to go ahead and end it, so we do that with an */. And remember, as a block comment, we can actually have multiple lines of text within here. So now we have that multi-line comment there. Let's go ahead and run our application. And once we run it, just as expected, our output is unchanged because the comment text doesn't affect the execution of our program. Now one of the cool things about block comments is they have a distinct starting and a distinct ending point. Well, because they have distinct starting and ending points, we can use them not only for multi-line comments, but we can also use them for comments within the middle of a line. So look down here where we write out the third line from app. Well, let's say we want to temporarily change that text that we're writing out. Well, we can take that text string and enclose it within a block comment. So that text for third line from app will now be ignored by the compiler, and instead we might write out some different text. So now let's go ahead and run our application. Instead of writing out third line from app, it writes out this is different text. Because again, the block comment allowed our comment to have a distinct starting point, the /*, and a distinct ending point, the */. So now let's take a look at nesting comments within a block comment. So we have our block comment up top here. So let's go ahead and start another block comment within this block comment. So we'll start out with /*, then we'll go ahead and add our //. And notice as soon as I do that, the second // is underlined in red. And that's indicating that we now have an error. And the issue is that you cannot nest one block comment inside of another. The way block comments work is that once the compiler sees the /*, it knows that a block comment is starting. So it ignores everything until it sees the first //. As soon as it sees that //, it no longer considers itself to be part of a comment. So when it sees the second // the compiler is simply saying, I don't know what that is. So whenever you use a block comment, we can't nest a second block comment within it. So let's go ahead and remove that inner block comment. Now with that gone, we can nest a line comment within a block comment. And you notice when I do that, there is no error. Because again, remember, the way that block comments work is that once it sees the /*, it ignores everything until it sees the */.